Time to get started.
Yeah, let's do that. So I think we'll start by talking about stack packs, and I revised the unresolved questions part of the RFC, and I think some of that will drive this conversation. And I'm trying to find that. After that, there's just some other bullets that we can talk about. So let me pull that up. I'll go ahead and share it, but I might let Jesse drive some of this.
Sphere is going to add a lot of commits to our Caesar repo.
Yeah, I'm not sure what that says about me as a human, or potentially the process, or us as a team. I don't know. It's a reflection of something.
Very iterative. It's great.
Yeah, it could be a positive thing. It could be a horribly negative thing. I don't even know. Okay, here we go. The first question: what happens if a mixin that already exists on the image is required? How does Lifecycle know? I think we talked about this yesterday, and I think I might have actually written this up higher in the RFC, that the detector would examine the stacks mixins.
Yeah, from the stack toml, right?
Right, from stack toml. Yeah, I think I wrote that up in the RFC actually.
I know Steven had a concern about that, which is that stack toml is usually written into the builder when the builder is created. And I guess what happens if someone updates the run image? Or, as I was thinking about it later, a better question would be what happens if someone provides a custom run image?
Yeah, like they use the stack ID but provide a different image. Is that what you mean?
I think we could still use stack toml though, but make it, we could still build one into the builder for the default case, but make it the responsibility of the platform to update it if someone's providing a custom image.
Yeah, that makes sense. I think Jesse mentioned, I think this is what you were talking about, Jesse, when you mentioned this, but like, could the mixins actually change between rebases? In which case, I'm not even sure you would have, well, I guess you could have the image metadata at that point.
So does stack toml live on the run image? Is that right? It doesn't, does it?
It doesn't, but you have
on the builder image.
But if during a rebase, you can look at the metadata.
Yeah, right? You could always overwrite stack toml with a new set of values.
You don't need the builder today to do a rebase, right? Isn't the rebase just take a new run image and just the image that you have?
Yes.
So we don't even technically have the builder yet. I mean, this will be introducing that, but
I think the things you need for rebase are different because you only need the run image. Makes sense. And you do have the new run image, so you could still grab those off a label and provide them to the rebaser with an input file.
It feels like we need the mixins for rebasing on like as a label or something on the run image.
So the mixins are already a label on the run image.
Okay.
So I think for most rebase cases, that is already fine.
That was a question I had on the application mixins RFC. I wasn't sure how we would know what like mixins to reapply during rebase.
Are we concerned about the, sorry, I just joined a couple minutes ago. Are we concerned about the case where you're doing a rebuild and you need to get the run image mixins to the right stack? Like the detector needs to have the run image mixins?
I think that's the more interesting case because the rebase is more straightforward.
I think that's the only case where I see a crossover, where there's a build that's happening on an image, and the image doesn't. We can't put, or it would be very controversial to bake the mixins into the stack that the user's running, right?
Yeah, I think we could bake in our best guess on Crate Builder. But then you can always, the platform can always recreate that data and pass it in, right?
I really don't like that. Because there's no best guess. Like you could evolve this to a point where like you have one build image and 30 different kinds of run images with different mix-in sets, and you're always using it with the same base build image or builder, right? Even.
Man, that seems bonkers.
I don't think it's that weird, right? It's like you have different because your build image can have everything. There's not a huge, you want to have one of them so you're not transferring it in a lot of places, but your run images actually get deployed and have their like surface area matters, right? And so I could see it being a very common use case to have one giant builder, but then swap between lots of different run images with mixins to build different apps.
Okay,
I could imagine that being
right.
a use case.
Right, that makes sense, but but they're not, those are sharing a stack ID?
Yep.
Or would you actually,
yes.
See, that
they're
I
all
don't buy.
bionic with different collections of
Yeah, but why not
right?
have, like I can see sharing an actual build image, but still having a different stack ID.
But the stack ID just means Ubuntu Bionic, right? Like,
but if you have a different run image, okay, so the only difference in the run image is the mix-ins. You'd still have is that what you're saying?
Exactly. All the stacks we're making, really different sizes, have the same, except for the one that's not Ubuntu Bionic, have IO stack or IO Buildpacks stacks Bionic as the thing. They just have different mix-in sets, and then the mix-ins are what validates the sets of packages.
The reason I believe that there's a default set of run image mix-ins is because every builder has a default run image. Now you can still override that, and if you override that, then you have to change the mix-ins from the default set. But because there is a reference to a single default run image, I feel like there is a single default set of run image mix-ins. There's not a list to pick from right now. But also we can just leave it out and then write it in. It can be the platform's responsibility to write it in every time. I'm fine with that.
I feel pretty strongly that we shouldn't make the assumption that it's the default one, and that we should, during the build, feed the run images mix-in list into the detector in order to make it happen.
There's a question though. So sometimes if you're not, sometimes when you run all the way, it's not even until export that you know what run image you're using, and sometimes the platform doesn't know what run image is being used. So the lifecycle can read the stack toml file and decide whether to use a run image or one of the mirrors. So there's no point at which the platform would be able to read the label and provide it. But I guess we can just read it off the label. The lifecycle can read it off the label at that point. And then,
yeah.
I guess we just need to, the only difference here, because the lifecycle still has to figure out what run image to use. And the lifecycle can read things from the run image. The problem is now we have to do that during detect. And we've never.
I think we could do it at extend. I think we could
do it for a resolution of mix-ins though too.
Yeah.
Yeah.
You need it earlier.
And right now, detect never talks to a registry or gets registry credentials, and it's the basis of our trusted versus untrusted stuff. So it gets a little hairy.
It goes back kind of to the prepare phase that we talked about, where like really you want to kind of validate your registry credentials and things like that. Like maybe it spits out a run stack, like its own stack toml from whichever stack it's destined to be.
That's a good point. When you say the platform, when you say the platform, you mean Tecton, right? Because like Pack could easily figure out what run image happens before
actually
the build.
Always specifies by default what the run image should be. So this isn't a problem in Pack, because Pack is the idea of local mirror config. So it's always going through its resolution process, but we don't require that of every platform.
Right.
the lifecycle can do the resolution itself. And that is useful for platforms that don't have as many hooks to provide logic and don't want as many credentials, stuff like that.
Tecton.
Yeah, Tecton.
So we introduce another phase that runs before the detector that is a pre-analysis phase that sorry, go ahead.
Yeah, I think that's been needed for many reasons. I think now we're just saying it's like a little bit more critical if you want to support stack packs as a platform, because that prepare phase is what's going to allow us to support things like Project Domo.
Yeah, that's actually a good point.
I mean, Pack can support Project Atomo without the prepare phase, right?
Yeah,
I feel like this would be the first thing that would make a prepare phase necessary for
like a
I guess
core
it's still
feature.
not necessary for
well,
Pack.
how do you?
Yeah.
Well, I mean, you could say that like providing us a list of build packs in a sort of like officially supported way or a platform independent way, that this is required for that, because like the only way Tecton can accept custom build packs is with some environment variable, and then that actually depends on how you're running Tecton, I guess. So I forget where I was going with that, but I think it's like this is maybe the first like core feature that you need it for. I don't know.
I'm not opposed to introducing the phase if we need it. I want to ask what's maybe a dumb question. Could we not do the resolution because the build is always going to end up happening on the image that needs to have the resolved mixins, right? In the end, the only image that needs to know about, the only time the build or extend needs to happen with the resolved mixin set is on the image that has those mixins.
Yeah.
I think it matters for detect, right? So if a build pack says, I can't run unless this mixin is installed on the run image, and there is no stack pack, but that mixin's already on the run image, do you pass that group or fail it? That's what's important, I think.
Well, I mean, this is why I'm saying this is probably not a smart question, but is there a way, like, are we sure that the resolution process actually needs that much information in order to identify a candidate group where we wouldn't need to go back and pick another group, right? Like, is it just the detector, instead of it failing during detect, it fails in a later stage, but because the group is so close to having passed, we don't want to actually move on to the next group? I think that's probably wrong. It makes the model more complicated for end users to think about it. That's why, like, I caveat this with, like, I don't know if it's, but it would solve the problem we're having without adding additional complexity if it were true. And so I want to think about that aspect of resolution. Does that make sense?
Yeah, I think it adds too much complexity. I feel like if you're going to do, the mix-in resolution, it feels like you need to have all the pieces up front to really explain this to somebody and then understand that it's going to work.
Well, if a group fails because the mixin isn't provided on the stack, you would probably want it to go on to a next group because there could be a group that doesn't need it. Okay, yeah. I guess then we don't have a choice. I just wanted to make sure we weren't.
I could particularly see this happening in the case you described the other day with Windows dependencies that may or may not be a mix, like stack provided. Like maybe the first group's like, I require it from the stack. And then if that doesn't happen, the next group's like, no, I can install this.
It was .NET Core on Linux. It wasn't Windows.
Oh, sorry, yeah. .NET Core. I remember there's something.
With ICU.
.NET.
Well, Microsoft stuff, but
yes,
that's a good point. It would be great to support that use case too. No, that's the thing Forrest cares about.
Okay, that'll take. This will take some more fleshing out, but I think I know what we need to do to write that up at least. Does that sound good enough to move forward then?
And what we need is
a new phase, or we need. Oh,
I think
Jesus,
for
I mean,
now we
like,
can say
this
for
is-
I think for detect can just accept a file with these mixins.
Okay, right.
Later, like you might need a phase to write that file for platforms that aren't like Pack, but for now we can just say provide it in a file.
Yeah, we could be real jerks about it and just be like, you have to give us that file. And then, so I mean, it's sort of like,
And that file has to accurately predict the run image that you're not going to specify until export, but whatever.
yeah.
And then we can make it easier for people later.
This ruins one of my grand schemes of having the detector image be able to select different run images based on, like if you have to know the run image ahead of time, but
Well,
I think it's okay.
Can it
We
not
don't need
give it? Can it not give detect all of them?
Maybe, yeah. Like
It's
there
like
are
it
ways around it. It just
requires or.
Yeah.
the problem is
Okay.
if we have like a manifest builder that only does detection and goes off to other builders that then do their build process, and those builders then specify the run images. Like I wonder if we're creating an architectural loop in a weird place, but I don't think I think this is the right thing to do right now, for sure.
All right. Jesse, do you want to talk about the caching issues? That, I don't know
Sure.
if
Yeah,
you
we're
brought them
talking
up in
about caching and restoring. This text here is a bit outdated after some discussion today, but yeah, so caching and restoring snapshots. The use case that I'm thinking of is if you have an apt stack build pack and you do an apt get update, it's going to update like the sources list before you do all your installs. And when you come back for your subsequent build, that for one thing, we talked about exclude, and you probably want to exclude the sources list from the final image, but you don't want that to be excluded in the cache the next time you come back, the next time you build. And so we're trying to kind of figure out what that looks like before anyone throws too much thought. Kind of what we're thinking what I'm thinking right now is that during the build phase, after running bin build for the stack pack, we emit 2 snapshots. One for everything that is not in the exclude list, which is not cacheable, and then everything that is in the exclude list becomes the cache tarball with 2 different layers. We emit 2 different snapshots as 2 different layers. I don't know if that makes sense.
Is everything you just said there written in that caching and restoring section?
No, this was outdated. This is just this morning, kind of been plugging away, thinking about it. Yeah, so the restorer actually will run with root privileges. That's one piece there here that I haven't talked with Joe about. I talked briefly with Emily earlier, and I think it makes sense for credential reasons as well as, yeah, I think it's the right place to put it. I think the restorer will go ahead and extract the snapshot tarballs as root, in this case, or privilege.
I don't think we have a choice, right? If we're going to construct a bunch of root on things.
Yeah, we talked about doing it in the builder, and that's what this paragraph talks about. Is restore would just leave the snapshots, and the builder would understand that it is a snapshot, and then do the restore. But it kind of, I think it conflates the 2 purposes of those binaries a bit too
Wait,
much.
so restorer actually writes them to the correct location, or it just writes them to a temporary location?
Writes them to the correct location.
How do those carry forward into the next container?
All right, works in Creator.
Good question, Joe.
Yeah. Oh man.
I mean,
forgot. Yeah.
do they, if they're both running as root, do they need to be separate containers?
Maybe instead of not supporting Creator, we only support Creator.
How, when you say writes to the correct locations, is this a Conoco feature where Conoco understands how to restore an OCI image layer on top of a thing? Or what do you mean by restore to the right location for these snapshot layers?
Yeah, this is not, Conoco doesn't do the restoring, so the Conoco writes the tar as just a typical layer, so like user bin something, and then as root, we'll just need to extract that to the root file system.
See, that's really complicated because there are these whiteout files, and it's like, how does Conoco? I guess Conoco never has to do
Conoco's
it.
already doing the filtering, so Conoco's already got the whiteout and stuff. So we're only capturing a small, everything that is not in their like disallowed list, basically.
feel like that would be possible for us. We could just extract the tar balls with a special casing for whiteouts, and we can ignore opaque. That part doesn't frighten me. But we can extract all these things perfectly in the restore container, and they're still gone by the time you run the build container, right? That's the real problem.
Is there a way we can write? I'm just wondering if there's a solution where we write to the image in the registry only, and then restoring is always running an image that has the layers pre-restored in it. But it seems like that wouldn't work well for fixed image platforms. You'd end up having to change them on every build. Or you'd have to rewrite your own builder image. Yeah, reference the builder by tag on your platform and then rewrite your own builder image every time. I don't know. It's not a good idea. You'd have to
so maybe this
pull
paragraph
policy.
is more accurate.
Yeah. Not good.
We are going to want to do this in the builder phase, I think, unless we combine the phases.
Yeah, is there? Yeah, I can't. I don't understand the reasons why we wouldn't combine them. Even though it seems like
I think the two
credentials thing.
Yeah, credentials is the big one.
Oh, because you need credentials to the. Oh yeah, that's a no. That's a no.
If it's a cache image, you need registry credentials. We've worked really hard to keep registry credentials out of the build phase, and even if it's a cache directory, right now we don't provide that to build, but that one's less scary. And just from a cleanliness perspective, it bothers me too to restore not during the restore phase, but I could get over that if it wasn't for the credentials.
Yeah, we could just call it something else. It's not restore. It's snapshot applier. And just forget that it's restoring. Because I guess I still plan on restoring the snapshots to the layers. So we'll still have, Buildpacks /layers/snapshot, and then the tarball, and also a snapshot toml to describe that layer. At least that's kind of what I'm proposing right now. And we'll probably have more than one snapshot. One for the things that were excluded, so that you can and those are kind of assumed to be restored on cache, and the ones that are not excluded would not be, I guess, kind of what I'm thinking.
Okay, what we can do in the restore phase is we can copy the layers from the cache to the layers directory, just like we do with normal layers. For normal layers, that's where they end up, but we can just copy them into the layers volume. Then on build, we can extract them. I think that solves all the problems.
Isn't that what I have written here?
Yeah, it is. Yeah. I do think that we'll probably want to denote these layers as being created by stack packs. So there might be something in a layer toml we need to add as far as like privileged equals true, perhaps.
Is that you said layer toml?
Yeah.
Yeah, okay.
So that we can just kind of blindly loop. I guess it's kind of weird because I don't think the builder really does anything with layer toml. So you still so maybe it doesn't need it because it already knows the stack group. So maybe the stack pack group.
Oh yeah, I can just look at
it can just go use those build pack names to assume that there's snapshots there, I guess.
Yeah, I feel like a lot can be inferred from the build pack metadata, and then also the fact that it's a TGZ sitting there in the layers directory. Okay, I think there's probably some changes in more detail that needs to be added to this section, but I think Jesse and I can do that unless there was any disagreement.
Yeah, we'll kind of push forward and see how that feels, I guess. I do think we'll have to see how. We don't want to create. One thing kind of about this is we're creating snapshots all the time, and I think there's probably a lot of times we don't need to create a snapshot if it's like a build only stack pack, because you only really need to run this as privileged, and then the build packs will now successfully do what they need to do, right? And so I don't know what that looks like, but if you have a good idea of what that looks like, Joe, then we can work offline on that.
It's interesting because for build time, in some ways, the exclude is the only thing you actually want to snapshot if you're excluding it and caching it, right?
Yeah, you want to exclude everything or something.
So is the build Is the build phase not running as root?
It is running as root.
Build is running as root.
Mhm.
Okay.
Stack pack build.
Yeah, we re-execute into build, not as root once we've completed the stack group.
I see. Okay, cool.
Back on the topic of actually restoring images or restoring layers as root on top of the file system, if that's a feature we could get upstream into Conoco, I feel like it's a safer place for it to be. With a lot more eyes on it. It seems like a generic feature, right?
Sure.
The ability to restore things.
Sure, it has more to do with the OCI spec than anything, though. But yeah, I
Right.
mean, that's fine. I think we
just-
could do that.
I wonder
I
if we
don't like it
can pull
when
it
we
out
have-
of like Containerd or something as a library.
Yeah. that
I've
sounds
like
good.
looked at how Containerd restores things to figure out what to do with Windows layers in the past. I'm not sure what hooks it provides us to import, but
I mean, it's restoring is like using kernel features, right? It's like doing file system mounts on top of each other. Forget what it's called. So I don't know if we
I
can.
mean, it's
we can do that.
creating overlay file systems and stuff that we aren't doing. But
Container D is? That what
Yeah.
you're saying?
yeah,
Okay.
We can't do that, but
But
maybe
we
it
could
has some
do-
logic.
It has some. I think we could look there for all the. At least use it as a guide, so we don't.
Yeah,
Overlay
maybe. I
things.
think it could make sense to upstream into Canaco. I mean, it'd be a pretty simple thing. Like, it already understands the OCI spec in order to create the file, so it's just going backwards from the snapshot.
The big problem is going to be Windows, but maybe I guess we're just not doing that for now.
Could even go into GGCR instead of Conoco. I feel like we've done a pretty good job of keeping low-level OCI stuff away from the project, right?
Yeah.
'Cause I worry about the depth of,
But-
I guess we tar up layers as extract, and we already extract layers, but we don't extract.
Yeah.
We
system level
already
layers.
extract layers onto the file system in restore.
Yeah, we just get to skip a bunch of stuff like whiteout files, right?
Yeah, I think the only difference is we skip things like whiteout files.
do we use GGCR at all to do that? No, we don't. We just do that raw, but that's okay in our case. We're making
I think if the only difference is whiteout files, it's probably
I think
fine.
it is.
Aren't
I
there
think
this
it is.
other there's this other thing that
There's
represents
OPQ files, but that
Yeah.
only matters when you're thinking about like a overlay file system. That doesn't apply to us. We'll
It's
just
a-
skip those.
it's a performance thing, right?
Yeah.
It lets them stop scanning
Yeah.
things. But then we gotta ignore that. And then what else, is gonna
Yeah,
come
so
out there?
Canico,
I think
the
that's it,
Canico
though.
snapshotter, it does some like interrogation of like it builds its own ignore based off of like what it's running on. Like I believe, isn't that right, Joe? I think you wrote that piece. Like it built an
Yeah,
ignore list
for-
based on like what you're running on. So it might be doing a lot of this already for us. So like
For
when it creates the
creation,
tar.
but then
Yeah.
I don't think we need that when we're like, do we like, I guess the question would be like, do we want to protect certain directories from being overwritten? Like if a snapshot contained either something it wasn't supposed to, or if the ignore list changed between versions of the lifecycle or something like that.
Which
we
when
would
it
wanna,
comes from
like-
a cache image or something that maybe isn't as well protected, I guess it is something we could protect against, right? But don't we do? Yeah, I guess they'd have access to update the SHA and everything.
I feel like we should just handle this ourselves.
So there are things like are there types of metadata like set UID bits and weird stuff that I think tar probably captures in some cases, but might not be good for tar to capture. Like how do OCI layers deal with that in a very generic way? Is whiteout and opaque really the only two exceptions, or is there more complexity here that we're not thinking
I
about?
think all the other complexity there isn't OCI specific. It's about tar archive formats. Like
yeah.
how do you encode all of those permissions? And
And
the answer for that's
And-
different from Linux and Windows, but we can do it. And there's tar utilities, and that can help us.
when it comes to getting the changes back out, we would reprocess the tarball anyways to like zero out the timestamps and change the the UIDs and stuff like that. So it would only be like if we needed to do things, it would only be for during the build process. But I can't actually think of anything.
Very good question. Are we going to zero out things when we restore
Yeah.
these? You think so?
Yeah, I think it's already doing that in exporter.
Well, yeah.
Not restore. We don't zero
Oh,
out.
not in restore. No, it's doing it in exporter. There's a new snapshot layer or like layers/snapshot.go, and it actually extracts the tarball and runs it through the normalize function.
Okay.
So what we're doing right now when we export those, individual layers is like we want them to be reproducible so we can, zero out the timestamps. We don't care about set UID. We'd probably never want anything like the permissions need to be exactly the same for everything. There's, normal number of normal configurations that apply to the files in those layers because we control that area, right? Now we're talking about the whole rest of the file system where some really weird stuff can happen. My point isn't that I think this should go in one place or the other. It's that because this is we can't just like take the same stuff we did before with tarring up layers that exist at the application level and apply that lower down. There's like a lot of other things that scare me there. And so like we probably want to do that at export time, like if we're going to zero things, but does zeroing timestamps break things like, are we going to break the password because it complains that, the last time this file was changed was before this, like we might not want to zero timestamps or maybe like I was talking to some of the Photon people a while back and they said they actually do like zeroing timestamps on the whole base image, but there are all these particular problems that you run into when you do that. There's like...
So are you suggesting that we won't have reproducible layers for stack packs if we don't do that?
We don't have reproducible base images, right? Like when you rebase your run image, right?
I think it's fine.
But this breaks if I run the same build with the same inputs, I get the same output, right? Because the base image was an input before, and now
there's no way to not break that because you don't know what updates you're going to get. Because the apt repository can change.
But that's like a meaningful difference. Now it would be in every difference, right?
That's an input, is what you're saying.
Yeah, that's an input.
Yeah, maybe that is like 99% of this, but there are other things like you could have. Those could not be inputs; they could be fixed within the build pack.
I think. How about this? Don't zero timestamps for whatever MVP we come up with, but when it's still experimental and we want to just get it out there, but then research zeroing timestamps in base images completely, right? Like what? So we do have full reproducibility of the image. Instead of solving half the problem.
We do kind of get
a feature.
Like right now, the way it's working is storing the snapshot itself zeroed out in the layers folder, but everything in that tar is not zeroed out. So when we do this restore phase, which we haven't done yet, if we don't use the zero tar reader, then so I guess that would be, it's like half the problem at least, I guess.
Why would we ever zero on restore? Or like, it seems like you'd always want to zero on export so that you end up with reproducible, like the layers in the registry match if they're the same. I
don't think we zero timestamps on restore. We're actually just creating files. Their creation stamps will be the time we
I was just looking at the Conoco one. We don't zero the Conoco snapshots that are created right now.
Export?
Well, export. Well, that's the tarball itself is being exported. Like we're not exporting. Oh, I think I see what you're saying. Maybe.
Yeah, layers snapshot.go I think does, but that's actually it's a lot easier because the layer is already OCI format, so we can just basically hand it over.
I actually think this isn't a problem at all, right? Because the only things we'd be restoring are things we don't export, so it doesn't matter if it's reproducible.
Yeah, unless something reads a timestamp from a place and puts it in another file, right?
I think we should let ourselves run into some of the weirder ones here.
Like what I'm worried about is even for the final image, right? One of the Ubuntu packages adds a user to Etsy password, and now Etsy password's timestamp is in 1980, whereas if it didn't add a thing to Etsy password's timestamp would have been a sensical timestamp. It seems like an arbitrary zeroing of timestamps we're applying on the base image that could cause problems that when you're talking about the final running container, unless we solve the problem for the whole base image, right, and have consistent timestamps for everything, it's just kind of looks like garbage, right? It's just nonsensical different timestamps for different files based on what the Ubuntu package happened to write to at different times. So I'd pretty strongly say let's not zero timestamps for any of the stack pack generated layers until we can handle the problem in the create stack level, right? Where we're figuring out a consistent zeroing of timestamps or consistent way of setting timestamps for the different files.
Okay, that makes sense.
Less work.
Yeah, that makes sense. Can we move on to the next topic? Because I think we've got that covered. Any final words? Okay. So Jesse, do you want to describe what we were talking about for rebasing and how different platforms might have different ways of providing the stack packs?
Sure. Yeah, this came up before when we were talking about rebasing an app and where during a rebase do you get the stack packs that need to run. So you know which stack packs need to run, but where do you get the actual stack pack, code so you can mount it in? I think a couple suggestions came out from that before. One was that you have to have access to the previous builder. In our case, I think we don't really want to update the stack pack code. Like during a rebase, we really just want base OS updates. We don't want any changes that may have occurred in the stack pack.
So during a rebase, you have access to the new run image, right? Won't the latest stack pack code just be on the new run image?
Well, we don't want the latest stack pack code. We want the exact stack pack code that was used last time.
Disagree.
Well, that's why.
Yeah.
So
that's why we
this
think
one,
it should be.
Yeah, it should be a spec where you pass in another image of where it can be the builder image, it can be the new run image, or it can be a companion image.
If we're saying that the stack packs are part and parcel of the stack, and you're moving to a new run image, doesn't that imply that you should be moving to the new stack packs?
Isn't that the strongest contract?
No, I think it's debatable. I think we should leave it up to the platform.
Then we shouldn't put stack packs
We're
and run
already
images at all.
coupling them with the image, so I feel like either those go together as a package all the time, or they don't.
Otherwise, we shouldn't put stack packs in the run image, right? If you're going to say this run image has a stack pack on it, but the stack pack doesn't have anything to do with the run image that it's on, it's just a way of distributing it. That seems very strange to me.
Yeah, that's a good point.
What I want to dig into is why do you want to make sure that the same stack pack code ran, or that you use the same extension code as was run at build time?
Yeah, the big reason is we want the rebase to be as stable as possible. We don't want any introducing some new bug in the stack pack to fail rebase. So the thinking was, if it worked before, it'll work again. To your point, that's not necessarily true either.
The builder also doesn't have a link to the original run image that was used in any build, so it doesn't matter if you put it.
Well, so one of the options we were thinking about for our platform is that we would put the stack packs in the actual launch image, and so our rebaser could get the original stack packs from the image it's rebasing.
Oh, like you put it in the app image?
Yep. Which I know you wouldn't want to do.
Would you white it out on top?
Sure, probably. But we don't care. For our platform, it's unusual for our customers to actually go get that image stays internal to the platform. So we don't really care that they would be there. But I mean, yeah, to your point, there's problems with that too. So it still makes me feel like giving the platform control over this makes sense. I did have an open question at the bottom though about I think we still need a sort of, or maybe multiple ways to produce those images. If we're going to put the stack packs in the launch image, that should be a sort of first class thing alongside putting them in the new run image or whatever the other options are.
What if there's the default behavior is it uses the one from the run image, but there's a check that says if you have the special layer in your launch image that has the stack pack in it, then it'll use that stack pack layer instead of the one from the new run image. I think it's weird because there's something has to copy from the previous, like something has to look at this ahead of time and say, I'm going to reconstruct build a new image that I'm going to run, right? It's like a feature that Tecton would never be able to use, but we have a feature that Tecton can use, which is just use the one from the latest run image anyways. So like we officially allow you to do that, but
what if we just use the one from the run image, but a platform that wanted to do something else could just copy the things into the run image, right? Before running the rebase.
It's the same thing.
Yeah.
It's different semantics.
But it's just like, do we build this into the rebaser as a special case, or just say,
I think
here's where the rebaser looks, but obviously you can put whatever you want there and it'll get found.
I think what Joe, what you care about is a spec and an agreement that the rebaser, we're okay adding a feature to the rebaser where it can consume stack packs from somewhere else during the rebase process, right? And I think nobody would say that we can't have that. It's just
and I think I'm fine with the default being get it from the run image. I actually thought that's not what you wanted for your platform. So if it is, I think that makes a fine default.
McNew, I'd look to you and say, is reasonable?
I was reading something else.
So to summarize, the run image would contain the stack packs. And so on rebase, the rebase operation would get both the stack packs and the builder to run them from the new run image. And during the rebase, in addition to swapping out the run image layers, it would also execute the new stack packs.
There's no builder. There's no builder during rebase, but it's like when you get a new run image and you're going to do a rebase, that new run image may have different code for the stack pack on it. And so rebase is less safe in this case, right?
Yeah, or it might be missing a stack pack, right? Completely.
If your run image author is real bad.
It needs the lifecycle component too to run the stack packs.
Mm-hmm.
Yeah, that's what I meant by the builder, right? Like, I'm not sure, does that come with the...
I think the platform should copy it in so that we don't have the idea of a run builder.
I think our run images should just have the lifecycle binary in them. I don't think you can't need the builder to do a rebase, right? I really don't like the idea of needing a builder to do a rebase.
Right now, lifecycle gets added to the stack when you create.
When I said builder, hold on. When I said builder, I meant the builder binary, not the builder image.
The extender binary. Or to be called builder on the run image?
No, you're right. Extender. No, you're right. It's extender.
Got it.
Yeah.
I think the platform should copy in the extender from wherever it knows to fetch it.
Doesn't that make Tecton really hard?
Yeah, I was going to say, and then we have to take into consideration the platform information, right? Like architecture and operating system.
I'd say if the run image has stack packs, it has an extender and the stack packs all on it together as a bundle. So all you need is a run image in order to do a rebase. Otherwise, it's...
So now when you create builder, you're going to output a run image as well? Or are we... No. But now you're taking the lifecycle and moving it upstream of where it is now. Like you have to bake the lifecycle itself in the stack images. That starts getting weird.
Just one makes it awkward to distribute that. If you're distributing stacks like we are at VMware, we already have a separate location we're distributing the lifecycle, and that's really going to start confusing things.
It's a little bit of a separate component, maybe. But there's already going to be code, right, on this.
So the concern is just about Tecton executing the rebase, right? The only dumb platform.
How about
that seems
like Tecton's already going to need. First of all, Tecton doesn't rebase right now, and if it did, it would need a container that runs a rebaser. Like you need to do something different in Tecton anyways. And if you're doing that, you might as well, in that container, copy the extender from your rebase container into the run image.
Doesn't seem weird to have access to a builder or a builder-like object in Tecton for a rebase that doesn't even exist yet.
Yeah, so I think, are you saying like builder, not the binary, builder like the image, right? Yeah, I agree with that. I think in that, like, I guess I was a little confused because it no longer sounds like rebase in the way that we know it, right? It's going back to that conversation about whether or not this is a rebuild to some extent. And then that opens up a different conversation probably.
I mean, it is essentially, it's a different kind of rebase. It's not, it requires containers. It's like a partial, it's a ABI safe rebuild, right? In the original proposal, I switched it to pack upgrade and said rebase fails if you need to do an upgrade instead. So everybody just uses upgrade, which will do the right thing. I don't know what the proposal for the UX is, but I agree that it is quite a bit of a different thing. To me, we're adding a lot of, we have the potential for an upgrade operation to require just as much stuff as a rebase operation requires today, right? You receive an image, you don't know what builder built it, right? You don't have to keep track of what builder built it. It could be in an environment, for instance, that's in production way far away, and you've deleted your original builder that built the image because the image was, it's a production image that was built a long time ago, right? I feel like we're creating this kind of dependency back to the very latest thing that's building your new images if we insist that you need the builder, the original builder that built your image.
I don't think anyone's saying we want the original builder. All we're saying is you need a thing that knows how to get an extender.
That's okay, right? I don't want that thing to be the builder. That's my strong opinion.
Yeah, we put builder in here because I think someone mentioned it last time, but I also think that having builders are really more conceptual anyway, right? So there may never have been an image that you can actually give it.
So if we stick it in the run image, right? Are we talking about this being a thing that actually would be stripped away from the final app image? Because I guess I'm concerned about putting the stack build packs in the final app image because they could create bloat, right? So if you have a stack build pack that has offline capabilities, you wouldn't want to do that.
We're not going to put them in the final app image, even if they're in the run image,
right?
Because we're using that as a base image, but we can easily just remove some layers.
Okay, right. So that's what I was asking. Cool.
Yep. And the same thing with the life cycle, right? If we put that extender binary, as much as people don't like it, in the run image, when we do that export, we don't have to put that in the final image, right? It's just
I get what you're going for. I think it's just an awkward place to distribute it and creates problems in all of our workflows.
So what if in order to support simple platforms, right, you can put the extender in there, right? And so when you do a pack upgrade, it doesn't have to do anything weird, right? But a platform, just like a platform can choose to pull the stack packs from the builder that was used to build the image or from the launch image itself or whatever, the platform can pull the extender from, like there's arbitrary input and platforms can decide which extender is appropriate for the process. Because
you run a rebase in a dumb platform, you already need the rebaser, which isn't in the run image. You need a container that has lifecycle components in it already.
But there's already a version mismatch, right? It's like you're never going to guarantee that the life cycle that's running during rebase, like what do you want that to match with, right? Do you want it to match with the life cycle that built the image? In that case, the kind of only safe place to put it is in the launch image that gets generated, or in a special image that always follows along with the other image. So I think we have a terrible version problem regardless, right? You're never going to be able to, I don't know what you're trying to match the extender binary to, if that makes sense.
I'm not trying to get the version perfect. I just think putting it in the run image is awkward, and there's another place we could put it that's less awkward and no worse.
Which is what place?
Which is the platform has it. The platform already has to know where to get rebase functionality, or has to have it built in. Platforms get extenders.
If you were to make a Tecton template, where would you put it? Yeah, exactly.
Yeah, I was going to say, so Tecton we would just use the builder, right? Like
we would use the lifecycle image, I think, which would have the rebaser binary in it and the extender binary, and then it would copy the extender binary onto a volume that gets mounted in the thing where we run, and then afterwards it runs rebase.
Why not just have a copy of it that you don't have to use in the run image next to the stack pass? You already have code in there that could change, right? It has to have a copy of some version of it in the run image, and then a platform can choose whether or not it wants to do some complicated thing where it goes out and tries to grab maybe potentially or another arbitrary version of the extender, or it can use the one that's built into the image, which is, for all it knows, no better than the one it's getting from the lifecycle image.
I care less about using the exact version it used before and more about using a platform API that the platform can use. I feel like letting the platform copy it in solves that problem better.
So you care about locking it to you care about the platform's expectations of the binary, not necessarily the image's expectations of the binary.
I mean, I care about both, but I think it should produce the same. But like, as long as all the API versions match, it should be fine, right?
Then don't we have that? You're pushing the API version problem to the other side then, because then you have the stack packs in the run image, right? That are in the run image, and you have a extender.
I wouldn't put them in the run image. Like, as a platform, I would mount them in anyway. I kind of feel like referencing them by image tags. I feel like I would not want to distribute those in the run image anyway.
Yes, I'm pushing it to the other side, to the Buildpack API side being the one that's at risk of not working.
Doesn't that mean you end up with like very old images that you're trying to rebase, and you have to go find a very old extender to work with?
Exactly. That's what I'm most worried about.
No, it's the opposite of that. I feel like
that's right.
When there's because we're not dropping support for the older APIs. I think what's hard, I'm more worried about the newest thing not being supported than the oldest thing not being supported. So if I have a new platform, and it's trying to rebase a very old image, I don't want it to have to pull every extender from the dawn of time to figure out how to work with it.
But if you're getting your run images from the newest run image, right, and you're getting your extender binary from the newest run image, then you know that the API between those things always works, and you know that it's generally always the newest version, right? We're not talking about using the extender in this particular scenario, even though it may be ideal in another case. We're not talking about using the extender and run image binary from the launch image, right? That would be really old. And so I'm just saying it's easy if those things are always versioned generally together.
If, for example, a stack provider wants to include a very, very old stack pack in their run image, they're responsible for providing the extender that works with it and its API version. Rather than can you imagine someone has a pre-1.0 stack pack that they want to include in their stack, and then my Tecton platform that I've set up has to go figure out where to get that extender from.
Yeah, but the Tecton templates that you have are passing arguments that old extender knows nothing about, to Emily's point, right? All the new stuff where it's trying to parse something out of a resulting file that is not present in that old version that came from this really ancient run image.
But that feels like a better place to manage backwards compatibility, right, between two components that are heavily controlled, rather than between every stack pack in the world and the extender binary.
So if we're never dropping support for older APIs, the safest thing to do is always get the newest version of the extender, rather than.
It assumes we don't accidentally subtly change some behavior while supporting a feature.
I mean, when we say we're not dropping, sorry, I'm really concerned about that term, because I've never seen that actually happen when we don't drop support for something. And then to think about, the life cycle that we currently maintain being the only instance that we're talking about, I can't envision other maintainers of other lifecycle, instances also having that same sort of requirement.
I got to drop because it's 3:00. Javier, all right, I'm not trying to dismiss your thing, but just as a summary for those who stick on for what my preferences are, I'd either run image and extender binary coming from new run image, or other option, run image and extender binary coming from the launch image, and keeping those things together is my preference. But sorry, thanks.
Yeah, I think I agree with that. I'll try and write up a little summary of this. Alrighty. Thanks everybody. I'll post a summary in Slack because there's a lot that we talked about.